Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to be going over how to do calculations involving scientific notation and how to figure out what number of significant figures your answer should have. So let's get into this. So here we have a few problems where they give us some numbers in scientific notation and in standard notation, and they want us to do the calculation and then figure out what number of significant figures our answer should finally be in. So if we look at A, they give us 2.17 times 10 to the negative 5, and we're going to multiply that by 10 to the negative 12, divided by 10 to the third, and then divide by 274.99. Now, you can use a calculator for this. So the point in these type of problems is not so much can you do the calculation, but can you pay attention to the number of sig figs that you need to put into your answer in, right? So that's really the focus of these sorts of problems. You can use a calculator to calculate this out. If you know how to use, if you know how to put scientific notation, if you know how to put scientific notation in your calculator, no problem. If you don't know how to put scientific notation into your calculator, then see my video where I go over how to put scientific notation into different types of calculators. So go to that video if you need help with that. Otherwise, one thing you can do is use the rule of powers, right? So if you don't remember, I'll explain a little bit. um, when you are multiplying and dividing numbers that are factors of 10, right? So 10 to the third, 10 to the 12, 10 to the negative 5, the rules are as follows. If you multiply those numbers together, if you have base 10, so these are base 10 with exponents or powers of 10, then when you multiply these numbers together, you add the exponents. So negative 5 is added to 12, and then that gives us 7, right? When you're dividing those numbers, if you're dividing factors of 10 or numbers that are base 10, then what you're going to do is you're going to subtract the exponent of the bottom number from the exponent in the top number. So I would be subtracting 3 from negative 5. Negative 5 minus 3 gives me negative 8, right? And then I would have negative 8, and I would add that to 12, and I would end up with a 10 to the power of 4, right? So I could kind of simplify using the power rules. But I still need to divide these numbers. However you do this, if you use a calculator or if you do it by hand, that's not the issue. We're going to get an answer. And so the answer we're going to get, give me a second, is going to be 7891. So here we calculate this out, we get 78.91. So then the question is, well, how many digits are we allowed to keep from this number? Can we keep all the digits or only some of the digits? So here, we got to look at here. So if you have powers of 10, those are going to be exact numbers. So powers of 10 are not going to matter as far as significant figures go. So we can ignore these. What we're going to look at are these numbers here. So if we look at this number here, we get 3 sig figs, the 2, the 1, the 7. All of those are significant. Here we have 1, 2, 3, 4, 5 sig figs. The rule when you're multiplying and dividing is that your answer should have the same number of sig figs as the measurement with the least number. So here we have 5, here we have 3, so our answer should only have 3. So we got to keep 1, 2, 3, drop the 1, and so our final answer is 78.9. And that's how it's done, ladies and gentlemen. Let's go on to B. Now, B is going to be a little bit trickier because we have this mixed operations. We have multiplying and dividing, but we have subtraction. And there's a different rule for subtraction. So whenever you have a mixed operations here where you're mixing, adding, subtracting, multiplying, dividing, then you got to follow the order of operations. And the order of operations is that you do what's in parentheses. And so here we have this in parentheses, and we're going to do the subtraction first. You do subtraction before you do multiplication division. Okay. So in this case, because this is in parentheses, we're going to do this. So I misspoke. You usually do multiplication and division first before adding and subtracting. But in this case, since it's in parentheses, you do what's in parentheses first. These parentheses don't really count because there's no operation going on inside the parentheses. The parentheses here are just kind of separate out and clearly separate this from this. So here we have parentheses, and inside the parentheses we have an operation going on in here. So we want to do this first. But there's a different rule regarding sig figs for this one. So let's go ahead and do that. So if we subtract it out, where's my calculator? So if we subtract out the information here, so we can take 37.8 minus 15.8 equals, and we get 22. Okay, so we get 22 from here. But is it 22? Are we allowed to write that number? Well, the rule when you're adding and subtracting is that your answer should have the same number of decimal places, not sig figs, decimal places as the measure with the least number of decimal places. So this has 1 decimal place, this has 1 decimal place, but look, my answer does not have a decimal place. So it's not 22, it's going to be 22.0. So now this is the answer for this, but I'm not done yet. I got to continue multiplying and dividing. So now I'm going to multiply and divide these numbers. And when I multiply and divide these numbers, I get 0.8731, 0.87, did I say 31? Yes, 31. Okay, so now I got to figure out the number of significant figures. So again, when you're multiplying and dividing, the rule is that your answer should have the same number of sig figs as the least number of sig figs in the numbers that you are multiplying and dividing, in the measurements that you're multiplying and dividing. So again, the powers of 10 are exact, so we're going to ignore that. Here we have 1, 2, 3, 4, 5 sig figs. And here we have 1, 2, and 3 sig figs, so there's 3 there. Here we have 1, 2, 3, 4. And here we have 1, 2, 3, 4. So the least number is 3. So therefore, our answer should only have 3 sig figs. So again, we're going to drop the 1, and we're going to report our answer as 0.873. Next, we have number D. So here, we only have multiplication and division. So when we calculate this answer using our calculator or using our power rules, one thing I want to point out is the 2.54. That's going to be the number of centimeters in 1 inch, right? So remember, that's going to be exact. So 2.54 is an exact number. And so the 10s to the power, the powers of the 10s to powers are also exact. So when we calculate this out, we get 5.84 times 10 to the 11. Okay, so now the question is, how many sig figs am I allowed to keep? So we said that this is exact, and this is exact. So our answer is going to depend on this and this here. So this number and this number. So remember the rule when you're multiplying and dividing is that your answer here should have the same number of significant figures as the least number of sig figures in the measurements you are multiplying and dividing. So if we look here, we have 1, 2. So that's 2 sig figs. Here we have 1, 2, 3. That's 3 sig figs. 2 is less than 3. So our answer should have 2 sig figs. So here we're going to have to drop the 4. I don't have to round because it's a 4. You only round this number here if the number you drop next to it is 5 or greater. So then my final answer is going to be 5.8 times 10 to the power of 11. Next, here we have this number here, or this operations, this problem. Again, 10 to the negative 4, 10 to the negative 2, 10 to the 3. Those are exact. We're not going to worry about those for our sig figs, but we do have to use them in our calculation. So we're going to calculate this out, and then when I calculate that out, I get 4.88. 4.88 times 10 to the power of 3. Okay, so once again, I have to figure out how many sig figs I'm allowed to keep. So remember, your answer when you're multiplying and dividing, the rule is that your answer should have the same number of sig figs as the least number of sig figs in the measurements you are multiplying and dividing. So if we count here, 1, 2, 3, 4, 5, that has 5 sig figs. This is exact, that's exact. Here we have 2 sig figs. The zeros here, the zeros in front of your number are never significant. So it's the 4 and the 7. So this is 2 sig figs. Here again, the 0 is not significant because it's in front. So 787, that's 3 sig figs. So the least number of sig figs is 2. So that means my answer should have 2 sig figs, not 3. So I'm going to drop the 8 here. And this 8 needs to be rounded to a 9. So my final answer is 4.9 times 10 to the third. Okay, next we have E. Again, we have this subtraction going on here. So again, following the order of operations, we're going to do the operation that's in parentheses first. Again, these parentheses are not really involved in anything. There's no operation going on in the parentheses. We're just using the parentheses to kind of separate out the numbers clearly. So we're going to have to do this calculation first. So let's go ahead and do that calculation. So here we have 45.773 minus 28.501 equals, and we get 17,272. So the answer here is 17 point, what was that? 272. All right, so that's what my calculator spit out, right? So, but are those all the digits that I'm allowed to keep? Let's see. So remember, when you're multiplying, when you're adding and subtracting, the rule is that your answer should have the same number of decimal places as the least number of decimal places in the numbers you are adding and subtracting. So here I have 1, 2, 3 decimal places, 1, 2, 3 decimal places. The least number is 3, so my number should have 3 decimal places. 1, 2, 3. It does. So I'm going to keep all of the digits and continue with the calculation. So now I'm going to multiply all of these numbers here, this number, this number, this number, and multiply and divide by these numbers. Remember, this is an exact number. So when I calculate that, I get 10.1508. So this is equal to 10.1508. Oops. Let me write it here. So this is equal to 15.1508. Oh, wait. Hold on a second. 10.1508. $10.1508. And so now the question is, how many digits am I allowed to keep? Remember that when you're multiplying and dividing, the answer should have the same number of sig figs as the least number of sig figs in the measurements you are multiplying and dividing. So here, up here I have 5. So that's 5 sig figs. Here I have 1, 2, 3, 4, 5, 6, 7 sig figs. Here I have 1, 2, 3, 4, 5. The zeros at the end of the number are significant when there's a decimal point. We have a decimal point, so those zeros are significant. So here we have 5 significant figures, and here we have 1, 2, 3, 4, 5, 6, 7, 8 significant figures. So the least number is 5. So our answer should only have 5 sig figs. So we can keep 1, 2, 3, 4, and 5. We're going to drop the 8. Because this is 5 or higher, we're going to round that to a 1. So our final answer is 10.151. And last but not least, we have this value here. This is exact. Now, this 5,280, that's the number of feet in 1 mile. So this is going to be an exact number. So this is going to be exact. This is exact. So the only measurements we're worried about are these two. When we calculate this out, we get 5242. So that's the number. How many digits are we allowed to keep? So again, when we're multiplying and dividing, the answer should have the same number of sig figs as the least number of sig figs in our measures. So we got 1, 2, 3, 4 here, and we have 1, 2, 3 here. So 3 is the smallest, so we should have 3 sig figs. So we're going to have to round this to 3. 1, 2, 3. Now, do not do this. 5, 2, 4. And then be done. That is not correct. Don't do this. Don't be that guy, okay? So this is, sometimes I run into this. So 524 is not a good answer. It's not a good rounded answer for 5,242. That's way different, right? So remember, when we're dropping significant figures, we're kind of rounding. So if we drop the number, then we got to replace it with a 0, like so. So that would be the right way to do this. So this would be 5,240. And notice I have 3 sig figs here, not 4, because the 0 at the end of the number is not significant unless there's a decimal point. If I put a decimal point there, now I have 4 sig figs. But without the decimal point, it's either ambiguous or it's not significant at all. And so for the purposes of this video, we're saying it's not significant. Okay, so that would be the answer for that problem. I hope this is helpful. If you enjoyed this video, if you learned a lot from this video, then please by all means like the video, hit that like button somewhere over here. Also, make sure that you subscribe to my channel. Hit that notification bell. When you do, make sure you click all so you can be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a particular problem or question you want me to cover, put that down below. If you have a topic you want me to cover, let me know. I would love to do that for you. Thanks for joining me and have a great day.